Hello, Gretko, Mrs. Tolle here. So today we're going to look into calculus, a question from November 2023. This is time of questions, guys. Make sure that each topic you practice as many questions as you can so that you understand the common questions that are asked per topic. Now, let's see what we have today. Okay, so the first question here is asking us, given that f of x is negative x cubed plus 6x squared minus 9x plus 4 is equals to x minus 1 squared minus 4 plus x. Now, determine the coordinates of the turning point of f. Now, how do we get the coordinates of turning point? Turning point, we know that gradient is equal to 0. So our first derivative must be equals to 0. So that's our gradient. Okay, that's what we know. F of x should be 0. So the first derivative of this would be, the first derivative will be equals to negative 3x squared plus 12x minus 9. That's our equation. Now, we are saying this should be equals to 0. So if it's equal to 0, we can now try to factorize what we have here. So if we take that, we get negative, I'll get a positive, sorry, positive 27. So here we have negative 3x squared. Two factors that we can use there is going to be minus 9x, plus 9x plus 3x minus 9. Okay, that will give us minus 3x there. Then we have x minus 3. Then we have got plus 3. X minus 3. So what you will see is going to be x minus 3, x minus 3, then also minus 3x plus 3. So our values of x here will be equals to x will be equals to 3 and x will gonna be equals to 1. Okay, already this one we have it because it's given there in the equation. So what we have here, if it's x minus 1 squared, once you see a squared, it means that at that point your graph is turning because it's touching the same point twice. So it's a turning point. So this is your turning point when it's given like that. Now, so we are looking at the coordinates of the turning point. Now we've got the x values. What do we need to do now? We need to substitute the y value. So for this one here that we have, we know that it's a turning point. So we know that the first one here should be 1 and 0. And the other one here is the one now that we need to punch in the calculator. So we can now punch in the calculator negative, what is it? Negative 3 cubed plus 6. 3 squared minus 9, 3 plus 4, we get 4. So it means that the other one here should be equals to 4. That's what we have. Now, the next question now is asking, draw a sketch graph of f. Clearly label all intercepts with the axis and any points that we have. So the good thing is that from our equation, what can we deduce? We can deduce the y-intercept. So we can come up with the y-intercept here because we know that that value there is a constant and it's a y-intercept. Then also the negative there, the negative also shows us the shape, give us the shape of the graph. So what if you see a positive here, it means that your graph is start what you call sad, then smile later. Then in this case here, when it's negative, it start by smiling, then actually become sad. So that's what you see. That's the shape that you see just by looking at the negative. Seeing the negative will tell you how your shape of the graph should look like. Then also when you're given like this, you already have one of the turning point. So and the other one, and also intercepts. So what it means here, we have got x-intercept, so it's going to be 1 and 0, then and 1 and 0, which is repeated. So it's 1 and 0, 1 and 0 like that. But this is one thing, so it's repeated. That's why it's squared. Then also we also have a 4 and 0. So these are your intercepts. Okay, now so we have the y-intercept, we have got the x-intercepts. Now we are good to go. So here these are x-intercepts. So now we can now come and draw our graph here. Okay, now from our graph there, let me see if we can move it here like that. Okay, so that's our graph there. Then what do we have in the graph? We are saying your graph is touching. Is this the shape? So it's touching there at 4. It comes down here. Let me see. So it's coming here. It's touching at 1. It goes up, it stands, it comes and touch and goes down like that. So what do we need to label there? We'll come then and label here. We have got 4, okay? Then we have got 1, then we have got 4 there. Then we have got what we have? We have got also the turning point, which is in this case 3 and 4. We put it there. Then we need to indicate that this is our y-intercept, this is our x-axis, okay? So y and x-axis should be indicated, and also the origin should be indicated. Then once you have something like this, then we know that you have everything in place, because you have the turning point, you have also another turning point, then you also have the intercepts. So in this case now, it means that your graph, you can get all your marks are correct. Then now let's see the next question here. Use the graph to determine the values of k for which negative x cubed plus 6x squared minus 9x plus 4 is equals to 4. We'll have 3 real and unequal roots. So what does this mean? It means that your graph, where it must cut the axis 3 times. So it must cut x-axis 3 times. That's what it means. So these are roots where it cuts the x-axis 3 times, and they must be different. So it means that we mustn't include 1, because once we include 1, in this case, you can see that it's turning at 1. So and our y value is 0. So it's our y value in this case is 0, because remember, we are now talking about shifting your graph up and down, because k is a constant. So it's going to change only the y value. So this one here is a constant. And what does it represent? It represents vertical shift. Vertical shift. So you're only looking at the going up and down. So what do you look at here? You look at the value that we have here, which is 4. Because what you know is that for it to have 3 unequal roots, it means that it mustn't go up. It must not go up in any way. But what must it do? It must go down. But again, it's limited, because once it gets here, it's going to also turn here at 3. That's what it means. So what it means that it must go down, but not, it's limited again in the movement to go down, but going up is no. It mustn't go up. Because once it goes up, it means that it's going to have only one root to the to the equation. So now what are we going to see now? We can now say, okay, in this case here, let's have our k. K should be from 0, but we don't need to include 0. So we can say less than, because remember, we're looking at the y value here. We're looking at the y value, and remember, it's up and down. So here is our y. Now, so here we have our k, but less than what? It must not exceed 4. It must not exceed 4, because once it goes 4 units down, it means that it will be touching at 0, and it will be turning at x-axis. And that means it will give us only one, one root. So in that case, we have 4. So it must be above 0. We must shift it 0 units down, okay? More than 0 units, but less than 4 units down, because it will now turn at the x-axis. Okay, now so that means that's our answer to that. The line g of x is equals to ax plus b is a tangent of f at a point of inflection of f. Determine the equation of g. Now, let's try it on a fresh page. So here, line of, this is a linear function. So linear function, what do you need to get the equation? So for the equation, you need 2 things. What do you need? You need gradient. Number two, you need a point. So these are two things that you need. So always for every equation, for linear function, you must have these two for you to come up with an equation. So now the question will be, where do you get these two values? Where do you get them? So let's see. The line here, g of x equals x plus b, is a tangent to f at a point of inflection. Now, so it means that we can get the point. We can get the point. So how do we get the point? We know that is a point of inflection, and the point of inflection, the second derivative is equal to 0. Okay, second derivative is equal to 0. I want remind, just don't forget, there's another way of finding x value or to your point of inflection, which if you knew about it, then it's a good thing. So let's just start with the first one, the common one. So first derivative, we got it, because first derivative here, we have the first derivative here. Let's just get it here. So now let's look at the second derivative. Okay. Because we know that at the point of inflection here, at the point of inflection, the second derivative is equal to 0. This is what we do to find x. We are only doing this to find the value of x. So here, this is going to be equals to negative 6x plus 12. And in this case here, if we equate this to 0, we're going to get our x as equal to 2. So our value of x in this case is equal to 2. Then what do? We need to substitute these 2 here in the original equation to get the point. Okay, so what do we do here? We're going to come here and substitute 2. So we need now f of 2, okay, to get the y value. So let's see that. So we're going to say negative 2 cubed plus 6, 2 minus, okay, minus 9 plus 4. This is what we get. We are getting 2. So it means that f of 2 there is going to also give us 2. So the coordinates, therefore, is the point of inflection is going to be 2 and 2. That's our point of inflection. Now, once we get a point, we now need the gradient. But how do we get the gradient? Remember, the first derivative of anything, first derivative represents your gradient. So first derivative represents gradient. So this first derivative is represent gradient. So what are we going to do? We're going to substitute to find the gradient. We're going to substitute f into the first derivative. We're going to substitute 2. We're going to substitute 2. So we get 2 there because we are now looking for the gradient. So we have a point which is 2 and 2. Then now we are going to find the gradient, which is f of 2, which we're going to say negative 2 squared plus 12 2 minus 9. Okay, then what do we get? If we punch that, let's see there. So we have got negative. It's negative here. Let me just correct it. Negative 3, 2 squared. I have 3 in bracket, 2 squared plus 12. Then you also have the 2 there, minus 9. We get 3. So here it means that the gradient is equals to 3. Do you see how we're getting the gradient? We are using the x coordinate to get the gradient at that particular point because we know that that's where the tangent is passing it. Now, so what are we going to do now? Because we know that gradient of the tangent and the gradient of the curve are equal at a particular point. That's what we are using. So we are saying at a value at 2, gradient of the curve, which is the cubic function here, is equals to 3, and the gradient of the tangent also is equals to 3. Now, let's see what we have now. We can now use this point here and the gradient, which we got. So here we've got the gradient, which we got as 3. So here we can say now, use our equation, y equals mx plus c. Now, in this case, we are looking for c. What is our y? Our y is equal to 2 is equals to our gradient is equals to 3. Our also we get plus c there. Our c there is going to be equals to 2 minus 6, going to give us negative 4. Okay, so here 2 minus 6 goes negative 4. So we can now simply write our equation now and say our equation therefore is equals to y is equals to 3x minus 4. That becomes our equation. Now, the next question is asking us, calculate the value of theta, the acute angle formed between G and x-axis in the first quadrant. Now, what is it that we're going to use now? We are going to use that angle of inclination that we know that tan, if done analytical geometry properly, you know that to get the gradient for a line, let's say here, for a line there, this here, and you've got the gradient here as our m, we are saying tan theta should be equals to m. Okay, so to find that angle, you are going to say theta is equals to arctan of the gradient. So that's what we are saying there. So in this case here, we're going to apply that and say our theta there, theta is equals to arctan of the gradient is 3. Okay, so gradient is equals to 3. Then we're going to say arctan of that, tan, okay, arctan of 3. Then we get 71,57, 71,57 degrees. So I think we understand each other in this case. Just make sure that you also, just to add something here, something to add. I just want to add something. The common questions that normally comes is where your f of x is increasing. And in this case here, we're talking of the gradient increasing. It means that the gradient is positive, okay? So gradient is positive from this point here to this point here, which you're going to say it's from 1 less than your x less than your 3. So that's where it's increasing. Where is it decreasing? Now it's decreasing. We are saying gradient is equals to negative. In this case, gradient is equals to negative when it's decreasing. So gradient means that gradient is the gradient is negative. So it's going down like that. So this part here going back there is decreasing. So it's going to be x less than 1. Then also it's decreasing where we are saying x greater than the turning point, which is 3. So that's where your f of x is decreasing. So those are things that you can also remember for next questions. Thank you so much, guys. Keep on practicing. I wish you the best. Thank you.